Hi students, I am B. Padma, Associate Professor, IT Department, GRIT. Now I am going to teach you microcontrollers and application subject. In our daily life, we are using so many smart devices like mobile phones, TVs, micro ovens, ACs, etc., which are equipped with microcontrollers. Whenever controlling operations are required, we can use microcontrollers. Before I introduce microcontrollers to you, let me explain some basics of my computer system. Computer system consists of CPU, memory, input and output devices. Let me share diagram. Just look at this diagram. As you know, CPU, Central Processing Unit, is the important part of the computer which is used to process the data. CPU also called as microprocessor. Let us know about main parts of CPU. Observe this diagram. Here, first part is ALU, Arithmetic Logic Unit. Second part is CU, Control Unit. ALU is used to perform arithmetic operations like addition, subtraction, multiplication, etc. and logic operations like OR and exclusive OR, etc. Next, coming to the control unit. It is used to control all types of operations in computer system. This is about CPU. Next topic is memory. What is memory? It is used to store data and to execute programs. As you know, we have different types of memories. RAM, random access memory, as primary memory, which is used to execute programs. ROM, read-only memory, as secondary memory, which is used to store data and programs. RAM is a volatile and ROM is non-volatile. I think you might have learned about memories in CO subject. Okay, students, now getting into the topic input-output devices. You know, without input-output devices, we cannot interact with the CPU. Some examples of input devices: keyboard, mouse, touchscreen, joysticks, etc. And output devices are monitor, touchscreen, etc. This is about computer system. Wait a moment. Look at this picture. It is a block diagram of microprocessor, nothing but CPU. It is consisting of ALU, set of registers, clock circuit, and interrupt circuit. We already discussed about ALU. Next, coming to the register part. Accumulator. It is a default register which is used in all operations of CPU. Working registers. This register set depends on the microprocessor type or company. Example, 8086 microprocessor is having AX, BX, CX, etc. registers, whereas 8051 microcontroller has R0, R1 up to R7 registers. Next part is program counter. Shortcut is PC. What is PC? Which is used to provide next instruction address. Whenever CPU is executing current instruction, it needs to fetch the next instruction to execute further. Using PC content, CPU can get the next instruction address. Next part is stack pointer, SP. SP provides top of the stack when we work with the stack memory. And next part is clock circuit, which provides clock pulses to the CPU. Without clock pulses, CPU cannot run. And last part is interrupt circuit. It provides interrupt signal to work with the internal parts of CPU and also external parts. All these parts are inside a single IC. Students, this is about microprocessor. Now, let me explain about microcontroller. Microcontroller is equivalent to microprocessor plus other parts. What are those other parts? Those are memories, IO ports, timers. Actually, when we look at microprocessor, it contains only ALU and control unit. Memories are not part of the microprocessor, but microcontroller is consisting of memories also. Now we will see block diagram of microcontroller. Observe this diagram. It has ALU, registers, clock circuit, interrupt circuit, and other parts also like IO ports, internal RAM, internal ROM, timers or counters. We already discussed common parts like ALU, registers, clock circuit, and interrupt circuit. Now let us learn about additional parts. First one, internal RAM and ROM. Internal RAM is used to execute programs and internal ROM is used to store the data and programs. Second one is IO ports. Using these ports, we can connect external devices to the microcontroller. Example, we can connect keyboards, LCDs, motors, buzzers, sensor, etc. Third part is timers or counters. Using timers, we can produce delays. What is the use of delay? Let us take one example, AC, smart AC. You have selected 16 degrees centigrade temperature. Now room temperature is 28 degrees centigrade. Then AC has to use its cooling element to reduce the temperature. Let us assume 3 minutes are required to reduce the temperature. Now AC has to run its cooling element 3 minutes to reduce the temperature. It starts the cooling element, waits for 3 minutes and stop the cooling element. How does AC know 3 minutes duration over to stop cooling element? Timers provides this waiting time, that is 3 minutes time, that is called delay. Students, this is about microcontroller. Now, using this knowledge, we will compare microprocessor with microcontroller. Look at this table. We are comparing microprocessor with microcontroller with the help of 4 parameters. Let me explain about these 4 parameters. First one, number of opcodes for moving data from external memory to CPU. So how many opcodes, how many instructions are present with the CPU to move the data from external memory to CPU. Second parameter is bit handling instructions. Here, every CPU is having number of instructions. Some instructions are handling the byte, some instructions are handling the bits. And third parameter is need of additional digital parts to work as a computer. So how many additional devices required to CPU to complete a computer? And fourth one is rapid movement of the data. So let us see first parameter to compare the microprocessor with the microcontroller. So first one is number of opcodes to move the data from external memory to CPU. So more number of opcodes are present with the microprocessor, less number of opcodes are present with the microcontroller to move the data from external memory to CPU. Second parameter is bit handling instructions. So microprocessor is having 1 or 2 bit handling instruction, whereas microcontroller is having more bit handling instructions. Third parameter is additional digital parts to work as a computer. So microprocessor required more additional digital devices to complete a computer, but microcontroller required less or no additional digital devices to work as a computer. And fourth parameter is rapid movement of the data. So here microprocessor is using rapid movement of the data from external addresses to CPU. Here, microcontroller is using rapid movement of the data within the chip. Students, I think you got clear idea about what is microprocessor, what is microcontroller, differences between the microprocessor and microcontroller.